that is violet, blue, next for green, next for yellow, orange and red. So take the readings only after placing the prism in minimum deviation position. Direct reading. So to take the direct reading, first of all, remove the prism from the prism table and observe the slit directly through telescope and note down the reading on the same scale, that is 52. So vernier coincidence is 12. So direct reading is same for all colors. Now next experiment is Newton's rings. So the aim of this experiment is to determine the radius of curvature of given plano-convex lens and required operator plano-convex lens, sodium vapor lamp, traveling microscope, etc. and formula for radius of curvature r is equal to dm square minus dm square over 4 lambda into m minus n, and this is the ray diagram consisting of a glass plate and plano-convex lens. So glass plate and plano-convex lens and 45 degrees inclination glass plate, traveling microscope, and these are the light rays coming from the source falling on the lens, and take number of the ring on x-axis, d square values on y-axis, and this is the corresponding tabular form, number of the ring and readings on left side and right side, d square. So this is the traveling microscope. So this is 45 degrees inclination glass plate. And this is black sheet, magnifying lens, a light source. So this one is glass plate. So this is the plano-convex lens, and this is the glass plate. So first of all, place the plano-convex lens. It is convex side on the glass plate. Whenever you place it, so there exists a small gap at the edges. So there is a small gap at the edges, means that we placed the plano-convex lens with its convex side on the glass plate. Now place the 45 degrees inclination glass plate under the microscope, and after placing a black sheet, place our glass and lens combination. So after placing glass and lens combination, under the microscope, adjust the position of microscope and inclination glass plate position until you get interference pattern, that is Newton's rings as shown. So you get a dark spot at the center, and move this screw and coincide the vertical crosswires with the fourth ring, that is the left side. On left side, coincide the vertical crosswire with the fourth ring. So vertical crosswire is coinciding with, and note down the reading on the scale. So note down the reading. So this is for the fourth ring, MSR is 16.4, and vernier coincidence is 25. Now again rotate the screw until the vertical crosswire coincides with the eighth ring on left side. Now it coincides with the eighth ring, and note down the reading, main scale reading and Werner coincidence. So reading is 16.55 and Werner coincidence is 12. Next, after that, note down the reading for 12th ring on left side, 16th ring, 20th ring. So like that, note down MSR values and Werner coincidence values. So of that VC into LC and total gives R1. So next after that, note down the values on right side. Now again rotate the screw until the vertical cross wire coincides with the fourth ring on right side. Okay, this is on right side. It is coinciding with the fourth ring. So note down the reading MSR and VC, and again note down the values on right side for 8th ring, for 12th ring, for 16th ring, for 20th ring. So this is R1 and this is R2. So difference between R1 and R2 gives diameter, and this is D square. After that, draw a graph between number of ring on x-axis and D square on y-axis. A straight line passing through origin is obtained. Now next experiment is air wedge interference. So the aim of this experiment is to determine the thickness of given wire using interference bands. Operators are two optically plain glass plates of same size, traveling microscope, etc. And this is the formula: T is equal to lambda L by 2 beta. And this is the ray diagram for the experiment. So two traveling microscope, light source. So this is the tabular form for air wedge experiment. So this is a traveling microscope, and this is a two plain glass plates consisting of a wire in between them at one edge. So whenever we place the wire, a wedge-shaped air film is formed in between the glass plates. So again, place the glass plate combination under the microscope, and you get interference bands as shown. And note down the reading for 0th fringe and 4th fringe, 8th fringe, 12th fringe, 16th and 20th, and note down the total values. So distance between 4 fringes, and this is the one fringe width after the distance of the fringe from reference fringe in the last column. Okay, next one is diffraction grading. So the aim of this experiment is to calculate the wavelength of different colors of mercury vapor lamp. And so before going to this experiment, so first of all, focus the telescope to a distant object until you get a clear image. So after doing this adjustment, so open the shutter and slit completely, and place the collimator in front of the light source. After that, observe the slit through telescope and change the position of collimator screw until you get the clear image. After that, decrease the width of the slit, means make the slit very narrow, and adjust the disc until the 0 of vernier scale coincides with 0 of main scale. So that is 0 position. So after that, rotate the telescope to 90 degrees, means the reading on the scale now becomes 0.90. Now the reading on the scale becomes 0.90. After that, place the grating stand and fix the grating stand on the prism table with a screw, and after that, place the grating on the grating stand. Now rotate the prism table until you observe the slit through telescope, and adjust that until it coincides with a vertical crosswise. After that, rotate the disc through 45 degrees towards the towards the collimator, and now it is in normal incidence position. Now observing through that telescope on left side of principal maxima. So this is principal maxima, and there is 7 colors on the left side. That is first order spectrum on left side, and this is first order spectrum on right side. So first of all, coincide the vertical crosshair with the red color line and note down the corresponding reading, MSR, VC, and VC into LC. After that,